When we plugged in -1, what'd you get?
1,
-1, Someone walk me through how you got that, por favor. Mateo.
So first you plug it in, which is f parentheses -1 parentheses equals -1 squared.
Uh-huh.
And then -1 squared is 1.
Why?
Because -1 times -1 is 1.
Very good. So my first point is -1, 1. Excellent. When I plug in 0, what do I get, Miss Alonzo? 0, Very good. 0, When I plug in 1, what do I get, Segi?
1,
1. So your first graph, I'll do mine in red to represent the pink one. It was -1, 1, 0, 0, 1, 1. Your parabola should have looked like this. That's exactly how yours looks? Wow. All right. Wait, what happened?
I wasn't here yesterday.
You weren't here yesterday. Okay, so Alfonso, all we're doing right now is we're plugging these values into this function. So we're saying, okay, what would 0 be if we had f of 0, right? So Alfonso, replace this x with a 0. What's 0 squared? So my point now becomes my x value and my f of x value. So 0, 0. Does that make a little bit more sense?
Yes.
Okay, awesome. Let's do the green one now. What do I get when I plug in -1? AJ. Me, I'll get to you. Go, AJ first.
F of -1 equals -1 squared plus 2. -1 squared is 1, and then plus 2 is 3.
Very good. So it's
-1 plus, comma 3.
-1, 3. Excellent. Mia, what do I get for the second one?
I write it out, but I have the answer.
What is it?
0,
0, 2 is correct. And the last one, Segi?
How do you get the +3?
Oh, hold on. Let me get the last one first. Go ahead, Mia.
1,
1, 3. How did I get the +3? Well, Segi, remember, you always do the exponents first. So what's -1 squared? And what's 1 plus 2? 3. Does that make more sense? Okay. So these are our 3 points. Let's plug them in. -1, 3. Boom. 0, what was it? 2? And 1, 3. Then we draw our nice handy dandy parabola. Question. What do you notice?
They are going the same way.
Ooh, they're going the same way. I like it. What else? Salucci?
It's a translation.
Oh, big time. It's a translation. Now, let me ask you this, Salucci. What kind of translation is it?
Vertical.
It's vertical, but where?
Up.
It went up how many units?
2.
Very good. Vertical
Whoa.
translation.
You're so smart.
He is so smart. Up 2 units. I can't spell units. Units. There we go. Hey, question for you. Look back at the green function and someone make a connection. Why did we move up 2 units based on this equation? Caden? You're so right. It's +2. And guys, this is what we're learning today. So we're going to be adding a number or subtracting a number from our function, and that will shift it either up or down. What would have to happen for our graph to shift down? It have to be a -2 or a minus any number, okay? So what I want us to know and what I want us to write down is we want to write ax squared plus bx plus c. Do you guys remember this notation for quadratics? Today, what we're focusing on is having a c term that shifts our graph either up or down. Matthew, what's up? Can we clap up Salucci? Sure, let's go. Good job, Salucci. The people appreciate you. The people appreciate you. David. Okay. Guys, what I want you guys to point out is I want you to focus in on this next piece of information. So when our C value is positive, when we're adding a number to our function, it moves to the green one. In other words, it moved up. When our C value is equal to 0, are we moving our graph at all? No, so it stays the same. Its vertex is at the origin. Do you guys see that? But when our C value is negative, where did it move? Down. So when our C value is negative, that's the red graph, it moved down. Our vertex is whatever that C value is, and 0 for the X. So it's 0 comma C, okay? Based on how much you moved up or how much you moved down. Mia, what's up?
Is it ever going to go the other way?
Like invert? It will, okay? And I'll explain when that happens, okay? Our first 3 examples are all going to be upright, but the last example we do, it'll invert on itself, okay? Now, the axis of symmetry, guys, we're only moving up and down. Do you guys agree? So our axis of symmetry is that dotted line that cuts our graph into 2 equal parts, right? That will not change, but I actually wrote it wrong on your notes. You have to cross this out, okay? And it's not y equals 0. What is the axis of symmetry for all these? What'd you just whisper to me, Michael? It's x equals 0. Very good, okay? X equals 0. That will not change depending on your C value. So that will always be x equals 0 for these examples. What is changing is what? The vertex. The vertex is going to move up or down. Is it going to move left and right with that different C value? No. Okay? Your axis of symmetry is still going to be x equals 0. You okay, Brayden? Okay. All right, let's go ahead and get started. So the first example I want us to do is letter A. We're going to do g of x equals x squared minus 2. Before we start plugging in, guys, I want you to take a moment and look at this minus 2 and try to predict what's going to happen to our graph. Translation where? Excellent. Down 2. Now, is this necessary? No, because we're going to plug in values that will help us figure out what our graph looks like. But it is helpful to be like, oh, I have an idea now of what's going to happen. Segi, did you have a question?
Yeah. When is it a translation?
Whenever we're adding or subtracting. Okay, so in this case, we're subtracting 2, so we knew it had to be a translation. Good question. Andrea?
How do you know if it's like vertical or horizontal?
So you remember how I said opposite world, non-opposite world? In this case, our parentheses are around the x. So like we can think of this as g of x equals x squared minus 2. Remember, outside your parentheses, it's going to be vertical. If this minus 2 was inside the parentheses, so it was x minus 2 like this would be a horizontal transformation or translation, okay? We will not see this, though, until later on in this chapter. So what you need to know is that all of these will be vertical translations, okay? Yeah, go ahead. Okay, so let's go ahead and fill in our chart. What happens when I plug in negative 2? Who wants to take the wheel a little bit? Who wants to try this one?
Right.
You got it, Matthew?
I said right.
Oh, not it. Okay.
Actually, I'll take it.
McCarvin, you're up.
Alright, so you would plug in negative 2 for x,
Mm-hmm.
and then that would give you negative 2 to the second,
Okay.
minus 2.
Minus 2.
Negative 2 squared is positive 4.
Okay.
And then you do 4 minus 2,
Yeah.
and that'll give you 2.
Excellent. So what's my point?
Your point is negative 2 comma 2.
Excellent. Negative 2 comma 2. What questions do we have on that first line? Alfonso? Where did the 4 come from? McCarvin, where did your 4 come from?
When I squared negative 2.
When you squared negative 2. Because what's negative 2 times negative 2, Alfonso? That's 4. Okay, you see that? Remember, guys, exponents always come first, and then you add or subtract or multiply and divide, okay? But exponents have to take priority based on order of operations. All right, we're moving on. Very good, McCarvin. Karen, can you do negative 1 for me, please?
Okay, first you put the negative 1 parentheses and then put the 2 outside.
Uh-huh.
And then you subtract 2.
Very good. So what's that point?
-1,
-1, -1. All right. Caden, can I get you to do 0, please?
G parentheses 0
Yep.
equals parentheses 0 squared
Yep.
minus 2, which equals 0 minus 2,
0 minus 2.
which equals -2.
-2. Excellent. So 0, comma, -2. David, what's up?
Remember we talked about earlier, you said you got translation there?
Oh, I didn't hear what you just said.
Remember what we talked about with the translation down to?
Yeah,
Is that it?
that is it right there. So this is now going to be my new vertex, which is now 0, -2. Do you guys see that? All right, let's keep going. What happens when I plug in 1? Gabe, what'd you get? Yep, Gabe L.
So you do 1 and then you put 1 squared, which is just 1 minus 2, which equals -1. And then you get 1 comma -1.
Very good. 1, comma, -1. And what's the last point going to be? We don't have to plug it in. Mia? 2, comma, ooh.
2, 2.
+2. Let's walk through this one. When G is, we plug in 2, we're going to get 2 squared minus 2. That should be 4 minus 2, which is a +2. Okay? Mia, what was your mistake? So we can learn from it.
When I multiplied it, I thought it was I just wrote it wrong. I wrote it incorrectly.
Okay. All right. So when we plug these in, let's see what we get. -2, comma 2, -1, comma -1, 0, comma -2, 1, comma -1, and 2, comma 2. Is it a parabola?
Yes.
Is it shifted down 2 units? Are we happy?
Yes.
Boom. All right, guys, just some quick little, see if we know what we're doing. I want axis of symmetry. What's the axis of symmetry? It's not 0, it's x equals 0. Thank you, Austin, okay? You guys will lose points if you don't put x equals 0. What's the vertex, Matthew?
The point like where it starts.
Okay, what is it specifically for this graph?
-2.
No, it's not -2.
Wait. Oh, yeah, 0, -2.
0, -2. Thank you very much. Who can tell me what the domain is for this function? AJ? All real numbers, baby. What's the range, though? I'll get to your question. Just give me 1 minute. What's the range? Christian? Yes. Y is greater than or equal to -2. Excellent. Go ahead. Why do we write x equals 0? Because, Alec, your axis of symmetry is the vertical line that will cut your graph in half, right? That it will be symmetrical about that line. It's basically a dotted line that goes vertically through your vertex, and the equation of this line is x equals 0. Okay, you got it now? All right, McCarvin, what was your question?
My question is, why wouldn't the axis of symmetry be -2?
Why wouldn't the axis of symmetry be -2? That's a great question. Now, what I want you guys to notice is, what is the equation of this line? Aren't all of your x values equal to -2 here? McCarvin, does the blue dotted line cut our graph in half? Is it symmetrical about that line?
Wait, I was saying for, never mind, that's what, yeah.
You see it now?
I was thinking of
Mia,
How do you get the range?
how do I get the range? Christian, how'd you get the range?
Everything's greater than -2.
All the values of your graph are all bigger than -2. Mia, does your graph exist anywhere below -2? Do you see that? So range is your y values. There's no part of the graph that's going below. Are you touching -2? And the answer is yes, because the vertex is at -2. Okay? What other questions do we have? What else? Cool? All right, let's do this. I want you guys to do B. We'll talk about it at the end, but try it all on your own. Go. All right, the answer's on the board. Talk about it with your groups. Compare, talk, go. Alrighty then. Peeps. Do we all agree on the graph? The last one? Sure thing. When x is 2. Hey, I need a volunteer to do the last one for me, please. When x is 2. Salucci?
So plug in the 2 for x, so it's g of 2 equals 2 to the power of 2 minus 5. 2 squared is 4 minus 5 is negative 1.
We good, David?
Yeah, wait, how's it not just one?
How is it not just 1? Well, remember, it's 4 minus 5. We're subtracting a larger number, so it has to be negative. Okay? The first one was also negative 2, comma, negative 1. Okay? All right. Guys, how would you describe the transformation that just happened here?
Go down 5.
Yeah, it was a translation down 5. Okay, now the second bit of this lesson is we're going to combine the transformation we learned in 8.1 and this transformation, which was a translation. So in 8.1, we talked about stretches and shrinks and when the graph gets flipped over on itself. Do you guys remember those? So we had skinny graphs, we had really wide graphs, and we had graphs that were flipped upside down like this. Do you guys remember that? Okay, so let's go ahead and look at example A in example 2. Let's look at letter A in example 2. It's on the next page. Before we start plugging and chugging, okay, I want us to anticipate what our graph should look like. So first and foremost, let's take a look at that plus 1. Who thinks they know what that plus 1 is going to do to my graph? Segi?
Translation up 1.
Very good. It's going to be a translation up 1. Now we have to look at the 4. Do you guys see the 4? The 4 is not being added or subtracted. What is the 4 doing to the x squared? Multiplying. And when we're multiplying, we're either dealing with a stretch or a shrink. Do you guys agree? Is this going to be a stretch or a shrink? Yes? It's going to be a vertical stretch. Why, Caden?
Because it's larger than 1.
Excellent. It's going to be a vertical stretch because it's larger than 1 and by a factor of 4. Karen?
How do you know if it's horizontal?
So if it was horizontal, where would it have to be?
Opposite
Inside the parentheses, in opposite world. So if it was a horizontal stretch or shrink, it would look like this, Karen. Right? It would be inside your parentheses, also being squared. In this case, it's not part of my base. Do you agree? So it's going to be a vertical transformation. All right, let's see if it happens, okay? Oh, also, guys, if I have this graph, right? I just want to take a second, and I stretch it. I pull it apart. I'm stretching it out. Would it get fatter or skinnier? So you agree that our graph should look like this when we're done with it, correct? Let's make sure that happens, okay? All right, let's plug in negative 2. So we're going to get g of negative 2 equals 4 times negative 2 squared plus 1. What do I do first here? Square it. What's negative 2 squared?
4.
So I have 4 times 4 plus 1. You guys with me? What's 4 times 4?
16.
What's 16 plus 1? 17. So my first point is negative 2, comma, 17. Let's do my next one. G of negative 1. 4 times negative 1 squared plus 1. What do I do first? Okay, what's negative 1 squared? What's 4 times 1? And what's 4 plus 1? So my second point is
Negative 1.
negative 1, comma 5. When I plug in 0, let's see what I get. G of 0 equals 4 times 0 squared plus 1. What do I do? Square. What do you get?
0 times 4.
4 times 0 plus 1. What's 4 times 0?
0.
0. And when you add 1?
1.
1. Excellent. So we have 0 comma 1. All right, when I plug in 1, I'm not going to do all the stuff over here, but what should I get? Should get 5. Very good. So 1 comma 5. And when I plug in 2, I should get 17. 2 of these points will not fit on my graph. Which 2 won't fit? The first and the last. So let's ignore those for now, okay? Let's go ahead and fill in the rest of them, though. Negative 1 comma 5 is going to be right up here. 0 comma 1 is right here. And 1 comma 5 is all the way up here. Look how darn skinny this graph is. They went on Weight Watchers, okay? They lost a bunch of weight. They were stretched. Imagine how skinny you'd get if there was a machine pulling you from your hair and your toenails. I know, it's pretty gross. But like, imagine, right, that you would get pretty skinny, right? If it was like pulling you apart. That's what we're doing to our graph, right? We're pulling it apart vertically, okay? Okay. Do you see the stretch happening? Do you see the shift? What was the shift we said in the beginning it was going to be? Up 1. Do you see how this graph moved up 1? Bingo. Okay? We're going to do one more example and then we're done, I promise, okay? It's into our graph. So for letter C, I want you to cross out -8 and I want you to cross out the 0 at the end. The 0 is actually a repeat. I don't know why that happened, okay?
-8? What am I looking at?
Oh. All right. So first, guys, let's anticipate what our graph's going to look like. Mia, you asked for one of these problems. This graph is going to be upside down. Can anyone tell me why this graph would be upside down? Mateo?
Opposite. Oh,
So, because the 1/4 is negative.
Excellent. Guys, underline that negative, whatever you need to know. Whenever you are multiplying by a negative in front of your x squared, it inverts your graph, so it's going to be upside down. Now, we don't have to have that memorized, because when we graph that, we're going to see, oh, it's upside down. But it is good to make that connection, because now you know what to anticipate, right? All right, the next transformation is, let's look at that 1/4, guys. Who can tell me what the 1/4 is going to do to my graph? McCarvin? Excellent. It's going to be a vertical shrink. By how much, McCarvin? By 1/4. Hey, if I had Play-Doh in my hands and I was to squish it, to shrink it vertically, what would happen to the Play-Doh? It would get fat, right? So check this out. Our graph not only is going to be upside down, but it's going to be nice and fat, like that. Thicker than a Snicker, okay? All right, and then we also have what at the end?
Translation.
Yeah, buddy. Translation up 4.
It's gonna be, less than or equal.
Bless you. Okay, peeps, let's plug in. Let's plug in -4, let's plug in 0, let's plug in 4. H of -4 equals -1/4 times -4 to the second power plus 4.
okay, pause.
Pause. Pause. Pause, please. All right. What do I do? AJ? Square. What's -4 squared?
16.
Hey, yo. So, hey, check this out. We have -1/4 times 16. Positive 16 or negative 16?
Positive.
Why is it positive?
Because 2 negatives equal to positive.
Very good. It's a negative times a negative. Now we have -1/4 of 16. What does that mean?
1/4 of 16.
Okay, what does that mean?
16 divided by 4.
16 divided by 4. What is 16 divided by 4?
-4.
It's going to be -4. Very good, Mia, because the 1/4 was negative. So we have -4 plus 4. What is that? 0. So my first point is what, peeps? Negative 4 comma 0. 0. Okay, the next one, 0. H of 0 equals negative 1 over 4 times 0 squared plus 4. Hey guys, we're multiplying here by 0. Do you guys agree? Wouldn't that just make this whole term 0? So don't we just have 0 plus 4? What is 0 plus 4? 4. So what's my second point? 0 comma 4. And my last point is h of 4. So we're going to go ahead and plug in 4. We're going to get negative 1/4 of 4 squared times 4 squared plus 4. That's going to be negative 1/4 times 16 plus 4. Still negative 4 plus 4, which gives me 0. So 4 comma 0 is my last point. Let's go ahead and plot these. Let's see what we get. Negative 4 comma 0, 0 comma 4, and 4 comma 0. Oh my gosh. Do you guys see it?
You're going so fast.
Do you see it? Number 1, is it fat? Hey-yo. Too many Snickers, okay? Second thing, is it upside down? Hey-yo. Is it shifted up 4 units? Hey-yo. Is everything we anticipated happening?
Yeah.
We love that for us. Guys, this is where we are stopping. Go ahead and turn these in.